Currently, artificial intelligence is undergoing a new evolution through the emergence of large language models. LLMs have significantly transformed natural language processing, excelling in tasks like question answering, summarization, and dialogue. Despite their success, LLMs face a challenge in capturing the attention of stakeholders in critical applications. This begs the question: do LLMs understand the literal meaning of a concept before using it, or they just simply generate fluent and grammatically correct sentences? Consider a scenario where you give explicit instructions to LLMs on how to respond to a question. It does the great for the first time, making a false impression on the user that LLM will always follow the instructions. Subsequent paraphrasing reveals LLMs ignore instructions, raising concerns about consistency. We conducted an extensive evaluation with 1,000 iterations running over 6 LLMs with 80 paraphrases from 20,000 data points in a morality corpus. Results showed that none of the LLMs crossed the 60% score on the sentiments, keyword matches, and similarities. The observed inconsistent behavior prompts an exploration on how different LLMs understand a single query. We created a task where LLMs must provide references to each sentence in a document. Varied correct answers among LLMs are ChatGPT gave 2, Bard 5, Llama 2, and with their internet accesses. And the ensemble of these LLMs would yield the better outcome. That's what our conclusions were. We found that independent LLMs lack reliability, whereas their ensemble seems to do well. An entailed challenge on explainability also follows consistency and reliability. Explanations lack focus in LLMs because LLMs do not have domain specific behavior. They tend to generate incomplete explanations and excessively verbose. We want user level explainability, which is step by step process and very focused and targeted. We put Llama 2 to the test, providing an input and asking for its own explanations. Then we threw a ball by blending the same input with a domain-specific questionnaire. This questionnaire compelled Llama to zero in on concepts that address its questions. The results, explanations were focused and spot on. We found that LLMs do lack a user-level explainability, but it is achievable through domain-specific guidelines. Inconsistency, unreliability, and unexplainability lowers the safety in LLMs. Consider this question where you ask, can I get addicted to ADHD medicines? ChatGPT, being safe with guardrails, tend to be unsafe by adding some unsafe sentences, whereas the Llama with blended questionnaire seems to do a better job in safety by proactive inquiring. We see that LLMs by themselves are unsafe, but we can empower them safety behavior through proactive inquiry. As we discuss challenges, it becomes clear that the missing element in LLM's operation is knowledge. This directs us to explore and investigate NeuroSymbolic LLMs. We introduce an innovative method for NeuroSymbolic LLMs through proactive inquiry. Employing knowledge graphs and documents enables us to anchor and contextualize user query, providing ample information for the generator to engage in meaningful dialogues. The incorporation of additional domain-specific constraints fine-tunes the evaluator, ensure adherence to instructions, and focus explanations, something we saw in the previous example considering the questionnaires. Across the three datasets, knowledge-intensive datasets, our initial endeavor outperformed GPT by 12% and surpassed instruction-tuned FLAN T5 by over 25%. It's intriguing to see the effectiveness of our neurosymbolic architecture utilizing a straightforward T5 for achieving the desired outcomes. The neurosymbolic design of LLMs presents a pathway to combine consistency, reliability, explainability, and safety together in an architecture, ultimately fostering trustworthiness in the generated outcomes. The article in AI Magazine delves into methodologies adopted to enhance neurosymbolic LLMs and introduces the CREST framework for the listed applications. The article also provides a plausible evaluation design for measuring consistency, reliability, explainability, safety, and eventually trust in LLMs. Thank you.